So our aim is to discuss the digital filters. As I told you in the analog filter also, during the analog filter discussion also, that filters are the networks which are used to process the signal based on their frequency. Okay. So in fact, any network will have some frequency response. So any network can be regarded as a filter. Okay. So similarly, in digital domain also, because every digital system will have some frequency response, therefore in fact all the filters, all the digital system could be regarded as a filter. Okay, but what we require the system to respond in a predefined way so that our aim could be achieved. Okay, and that is, suppose we have some requirement from a system, we require some system to behave in a certain way so that it have some desirable frequency response. So designing a digital filter is the main task. Okay, so designing a digital filter is the main task. So as we have discussed many a times that digital system could be divided into two parts. One is infinite impulse response systems, the systems whose impulse response is infinite duration. Another one could be finite impulse response system, where the impulse response is of finite duration. Infinite duration means, for example, UN. UN is an infinite duration signal. If suppose we have some system whose impulse response is UN, then it is referred as infinite impulse response system. But if suppose we have signal like this having the finite duration like u of UN minus 3, then it will be referred as finite impulse response system. Okay, so similarly digital filter can be divided into IIR filter or FIR filter. Okay, depending upon their frequency responses, depending upon their impulse responses. So what is FIR systems? We have studied it in the last semester also, the fourth semester, where we elaborated the impulse response by an equation, by the difference equation. But if we take it to be FIR system, could be FIR systems are basically those systems which depend upon the inputs and differences of inputs only, not on the output, so that there is no feedback. So if there is an output yn and there is an input xn, then there is no feedback. Feedback means yn is never fed back to the system. It is only the inputs and delays in input which cause the output. Okay, so this kind of system is called FIR system, where input is fed to some, let us say this is time delay, so that it gives you x n minus 1, x n minus 2, and so on. And then we have some summation kind of a thing, which takes its input and then fed to the output so that we have it output. So the signal always flow in forward direction as far as FIR is concerned, finite impulse response systems are concerned. In infinite duration, in IIR systems, what happens in IIR systems? What happens is that there is a feedback. There is a feedback. Like if there is an XN, then there will be some time delay. I mean, this is rough plots just to give you an idea. So that if Yn is this, Yn is here, Yn is here, then it is fed back to the input. This discussion will lead to know you about the what is the difference between IIR digital filter and FIR digital filter. So whenever there is a feedback, the impulse response becomes infinite duration and the system is called infinite impulse response system. Okay. Many complex methods which can be used to design a digital filter. Okay. And elaborated discussion is required for that. We'll be discussing few of them. For example, suppose we have an IIR infinite impulse response. IIR stands for infinite impulse response digital filter design. So one way to design a digital filter is to have an analog filter and then we take the samples and make it to be a digital filter. For example, suppose we have an analog filter, because an analog filter will have some transform, let us say HAS. HAS stands for transfer function for the analog filter. Suppose we have an analog filter whose transpose is this. We can convert it to its time domain signal, यानी कि impulse response, because transfer function का when we transfer S domain signal to T domain signal, we will lead to an HAT, which is impulse response of the system. Then we can have a sampling. Let us say at the rate of T. T is the time period of the sampling frequency. Okay? So that it leads to a sampled version of HAT, which can be written as HNT, and this HANT will lead to an this will be discrete time system, and this will be discrete time system. This will be sampled version. So that impulse response of this is what the impulse response of digital filter is. This is what the impulse response of digital filter, and when we transfer it to Z domain, we will have HZ. So designing a digital filter means that we require this function HZ. Once we have HZ, we can realize it. we can realize it by using different components. So this kind of design which uses HAS to find out HZ is called impulse response invariance. That means that is as if the sampling is done properly so that we can obtain HZ from HAS. Okay, but it has the limitation that the sampling frequency which is reciprocal of T is not high enough to avoid aliasing. Aliasing means there is an error caused by aliasing, so it cannot be avoided. So this is the limitation of this impulse response invariance mechanism. Okay, so what we do in impulse invariance transformation is impulse invariance transformation में हम क्या करते हैं? Basically, if we have this kind of factor, this means there is a pole at Pi. Let us suppose there is a pole in Pi in HAS. HAS is given. That means analogs filter का हमें transfer function is given HAS and it has a pole at Pi. Then it get converted to 1 minus e raised to power Pi Z inverse in Z domain. Okay. So that the transformation is, what is the transformation? Z is equal to e raised to power st. This is the transformation which can be used to obtain the stable transformation, which can be used to transfer HAS in S-plane to a stable HZ in Z-plane. To a stable HZ in the Z-plane. Okay. This is because, as you know, that if we talk about S-plane is this. Okay. S-plane is this. What is S? S is basically sigma plus g omega. Sigma plus g omega. So the left hand side, a signal is, a transfer function is, a system is stable when this left hand side is in the, when ROC is in the left hand side. Okay. This transformation. Then in Z plane, this left hand side ROC will get transferred to inside of the circle, in the Z plane. So that is how we can obtain a stable transformation from S plane to Z plane. S plane to Z plane, and this is what is impulse invariance transformation. Impulse invariance transformation, because it allows us to transfer a function in the S plane to the Z plane so that a stable HAS gives you a stable HZ in the Z plane. Okay. This is the transformation. if we use this transformation, we will